figure shows two rays of light from point P on an object O. These rays are incident on a plane mirror A. On figure, continue the paths of the two rays after they reach the mirror, hence locate the image of the object O. Label the image I. This is what we call a ray diagram. The main importance of drawing the ray diagram is to locate images. Let's take the first ray. Draw a normal for this ray which is perpendicular to the surface of the mirror. This is the angle of incidence. On the opposite side of the normal, measure the angle of reflection. So, this is the reflected ray perfectly where angle of incidence equals the angle of reflection. Let's do the same thing for the second ray. This is the normal which is perpendicular to the mirror. Measure the angle of incidence and take the angle of reflection. This is the second reflected ray. Now we are going to make extensions for the reflected rays. And remember, reflected rays, not the incident rays. So, when we make an extension back into the mirror for the first ray, this is what we get. And this is an extension for the second reflected ray. The point of intersection between the two extensions. This is the place where the image will be formed. Of course, if you measure the distance between the object and the mirror, must be exactly equal to the distance between the mirror and the image. In most of the questions, you don't need to measure angles. You can just make it by eye, but your diagram must look good. This is I, which is the image. This common question, which is usually for 2 marks, 1 mark is for 2 approximately correct reflections of 2 rays. This is 1 mark for reflecting the rays correctly. The second mark is for rays projecting back to image in correct position. So the second mark is for the extensions and the position of the image. Question B. State the law of reflection. This is a simple question. In any reflection, angle of incidence must equal to the angle of reflection.